Since, artificial intelligence, or at least discussions of it, are everywhere now, if not the actual application of it, can you provide an example of how AI can be used in conjunction with analytics and model predictive control? Because I would seem that this would be a pretty ripe area for its use.
Absolutely, and it's certainly in its infancy right now with manufacturing for sure. Being so new, and there's different approaches to how you can implement AI. Let's kind of talk about an example really of how artificial intelligence is used in conjunction with analytics and model predictive control in the context of our smart manufacturing facility, for instance. So imagine a smart factory that's producing semiconductor chips. The goal is really to optimize that manufacturing process for efficiency, yield, and quality, the same factors that we've been talking about earlier on. But, you know, here's more how AI analytics and model predictive control can kind of work together. So, as in our previous examples, we still begin with data collection. It always starts there. It's important to remember that when dealing with AI, the larger our sample size for training, the more accurate that our models are going to be. And this is really the historical data that's used to analyze and identify patterns and correlations that AI leverages very heavily. And when we talk about that, we're really talking about machine learning models. Uh, and these models are applied to predict potential issues or deviations in a manufacturing process. So, for example, AI algorithms can anticipate variations in chip quality based on historical data and those real time measurements that are coming in. The predictive models can identify subtle changes in process variables that might lead to defects or reduced yield. So, for instance, AI can help identify if a change in the gas flow rate is going to affect chip quality. This prediction is really based on training models and historical data that has been configured to tell the model when a good or a bad chip has been produced. Based on that feedback, the machine learning model can better predict next time whether those current parameters are going to yield a bad quality chip. And so, in turn, allowing for that corrective action up front is going to help us reduce any losses on that product, especially when it comes to a very expensive processing process. So, as we discussed a little bit earlier, model predictive control algorithms, they take in multiple variables. Those variables can come from a machine learning algorithm that we've just touched on. And the AI system is designed to adapt and learn from the ongoing manufacturing process as new data continues to feed that model. And AI models are updated to account for changing conditions and process dynamics. This adaptability really ensures that the predictive insights remain accurate over time and are still relevant even as the manufacturing environment and the equipment may lose efficiency over time. So really, in this example, AI, what I like to say is AI enhances predictive capabilities of our model predictive control by continuously updating and improving those process models. It helps the smart factory maintain high quality production and efficiency and adapt to changing conditions, ultimately leading to an improved manufacturing outcome and reduced operational costs. But at the end of the day, I do consider it, as of right now in its current stage, a a way of us basically being able to enhance what model predictive control has already brought to the table, by bringing in those different process variables and allowing that model to say, this was a good manufactured chip and it happened with these conditions, and this is a bad manufactured chip. It happened under these conditions, and that's happening every single time that a unit is being made. It feeds that model, and the more training data that we have, the better that that model will get over time.